Hello everyone, welcome to the Click Physics 1 course. Today we're going to learn about vector subtraction, and by the end of this lesson you will be able to subtract vectors using both the geometric and algebraic methods. So let's begin with a simple question. What does subtraction usually mean? Well, if I say 10 minus 3, you know that we are taking something away. However, vectors are different because they have both magnitude and direction. This means we cannot simply subtract their numbers, we must also consider where they are pointing at. And vector subtraction is subtracting one vector from another vector, and there are two methods for finding the difference between two vectors. We have geometric method and the algebraic method. Um, and when subtracting vector b from vector a, we write r equals a minus b. And remember that this also can be written as r equals a plus parenthesis minus b. And what does this mean? It means that before subtracting vector b, we must reverse its direction. In other words, if I had to say it, subtraction of vectors is actually addition in disguise. We change the direction of the vector being subtracted and then work with it. Now let's look at the geometric method. The first method is the head to tail method. To use this method, we have some couple of steps in here. First, place the tail of the second vector at the head of the first vector. And second, we continue the process if there are more vectors. And 3, we draw a vector from the beginning of the first vector to the end of the last vector. And for the final step, this final vector is called the resultant vector, as you can see in this diagram. As you look at the diagram on the screen, notice how we move from one vector to the next until we reach the final point. The resultant vector tells us the overall effect of all the vectors combined, and there's also an easier way to visualize vector subtraction. So first, we place vectors a and b so that they start at the same point or origin, the same origin. And second, we draw a vector from the head or the tip of vector b to the head of vector a. And finally, this new vector represents a minus b. So I personally find this method easier because it allows us to see the difference between the two vectors immediately. If vector a is longer or points in a different direction than vector b, the resultant vector clearly shows the difference. Now let's move on to the algebraic method. Well, if two vectors a and b have an angle theta between them, we can calculate the magnitude of their difference using the following formula written in here. R equals the square root of a squared plus b squared minus 2ab cosine theta. In this formula, R is the magnitude of the resultant vector. A and B are the magnitudes of the two vectors, and theta is the angle between them. You may also notice that this formula looks very similar to the formula for vector addition, and the only difference is the minus sign before the last term. That small change tells us that we are finding the difference between the vectors instead of their sum. And here is a worked example in here. Suppose vector A has a magnitude of 6 centimeters, vector B has a magnitude of 5 centimeters, and the angle between them is 60 degrees. And in here, we must find the resultant, or R. So here are the solution steps in here. Well, R equals the square root of 6 squared plus 5 squared minus 2 multiplied by 6 multiplied by 5 multiplied by cosine 60 degrees. And since cosine 60 degrees is 1/2, the equation becomes R equals the square root of 36 plus 25 minus 30. This gives us the square root of 31, and using a calculator, we find that R is approximately 5.57 centimeters, and that's our answer. And that's it for today's lesson. Thank you for watching.